Hmm. In this question, we are asked to calculate force between two parallel current carrying wires, 10 ampere and 15 ampere, separated by distance 30 centimeter over a length of 5 meters. When two wires carry current in same direction, the nature of force between them is attractive. So either the answer should be 5 into 10 to the power minus 4 Newton attractive, or 1 into 10 to the power minus 4 Newton attractive. The options with the options with repulsion as nature of force can be eliminated. Force between two parallel wires expression is mu naught by 4 pi 2 I1 I2 divided by 2 I1 I2 divided by d into L. Simplified version of mu naught by 4 pi is 10 to the power minus 7 into 2 into 10 into 15 divided by, we are taking distance in terms of SI units, 30 into 10 to the power minus 2. Over simplifying this, our answer is 5 into 10 raised to minus 4 Newton attract. In this question, we are asked to calculate what is the net force acting on a square loop placed near a wire 2 centimeters, and the directions of current in the square loop are mentioned in the figure. The edge length of square is 10 centimeter and the current flowing in the square loop is 15 ampere. The current flowing in the wire is parallel wire is 25 ampere. Now, just to eliminate the options by taking into consideration the direction of currents. The direction of current in the edge length AB is same as that of the direction of current in the wire, and the direction of current in the edge length CD is opposite. So AB and the wire, the force will be towards the wire, and CD and wire, the force will be away from the wire, because the currents are in opposite direction. It is going to have the nature of force between them will be repulsion. Now, eliminating the options, the greater magnitude of force is of attraction. So the option will be towards the wire. The square loop is attracted towards the wire. So options B and D can directly be eliminated, as the net force is attractive and is towards the wire. To calculate the net force is force on AB minus force on CD. As usual, the formula or expression is mu naught by 4 pi 2 I1 I2 divided by D. Now, distance between edge length AB is 2 centimeter, and distance between edge length CD is 2 plus 10, which is equal to 12 centimeter. LCM between 2 and 12 is 6. So the numerator values are same. It will be 6 minus 1, which is 5, multiplying 2 I1 I2. 2 into 25 into 50. So 2 into 25 is 15. 15 into 2 into 25 is 50. 15 into 15 is 750. So mu naught by 4 pi simplified is 10 raised to minus 7 into 5 into 750 divided by the denominator, as we have taken LCM, it will be 12 into 10 raised to minus 2. 12 ones are 12 6 are 6 into 5. So the option with 3 as the first coefficient, or first 3.1 into 10 raised to minus 3 Newton towards the wire as the final answer. Okay. 3 wires A, B and C carry currents 10 ampere, 20 ampere and 10 ampere respectively. Distance between each wire is 10 centimeter. We are asked to calculate force on wire C, where length of all wires or length of each wire is equal to 15 centimeter. And where will the force on C be directed? Since all the 3 wires carry equal currents, and when wires carry equal currents, the nature of force between them will be attractive. Force between C and A is also attractive. Force between C and B is also attractive, but force will be directed in the direction of greater magnitude. So force between CB will be greater than force between CA. Therefore, we are supposed to calculate net force will be FCB minus FCA. Force per unit length, or force, is calculated by the equation mu naught by 4 pi. Let's write the constant terms first. Mu naught by 4 pi 2 I1 I2. I am subtracting the I1 I2 terms. I1 I2 in first C and B is 10 into 20, which is 200. I1 I2 in A and C is 100 into length of each wire is 15 into 10 to the power minus 2. Upon simplification, we will have the final answer 3 into 10 to the power minus 5 Newton, right? We can directly eliminate 2 options which are left, because the product of I1 I2, the magnitude of currents, the magnitude of product of currents is greater in case of C to B. So therefore, the wire C is directed towards the right. The force is directed towards right. We can eliminate the options which are left. In this question, we are asked to calculate force per unit length between two parallel current carrying wires carrying equal currents 30 ampere separated by distance 5 centimeter. The expression to calculate force per unit length is given by F by L equal to mu naught by 4 pi to I1 into divided by D. Simplified expression for mu naught by 4 pi, simplified mathematical value is 10 to the power minus 7. 2 into 30 into 30 divided by distance 5 centimeter in SI terms 5 into 10 raised to minus 2 meter. 5 ones are 5 6 are. So upon calculating, we will have 360 into 10 raised to minus 5. Since we have the options in 3.6, so taking two decimals this side, we will have the answer 3.6 into 10 to the power minus 3 Newton per meter, which is first option is the right answer. A square loop in this question, a square loop is placed near a parallel wire, and the situation is given in the figure. From the options, which of the situation is correct? By observing the directions of current in the nearest edge length, the direction of current in the nearest edge length of the square is opposite. So the magnitude of force the magnitude of greater force will be repulsive, and the farthest edge length or the farthest parallel side of the square loop with respect to the wire is same, and but the magnitude of attractive force will be less, and the magnitude of repulsive force will be more. Therefore, the square loop will move away from the wire. First option is remain stationary. If it has to remain stationary, then the force between the edge lengths should be equal and opposite, so it is not the case. If the force has to be, or if the square loop has to move towards the wire, then magnitude of attractive force should be greater. If the force, if now the force of nearest edge length is repulsion and it is greater, therefore the square loop will move away from the wire, and option C is the right answer.